Today we'll be demonstrating how to set up and use a CM220 system from UIC Inc. to perform a total carbon analysis by combustion and coulometric detection with the CM5200 autosampler furnace and the CM5017 coulometer. Assembling a model CM5017 carbon coulometer. Parts included: the CM5017 base unit. The display unit includes a monitor and keyboard. The base unit also includes a USB flash drive for data storage, a US or European power cord depending on your exact model, a serial cable, Ethernet cable, a 15-pin cable, a power conditioner with US and European versions available, Teflon tubing, a pack of 10 small unions, a pack of 6 check valves, the cell assembly kit, cell reagents, and the operation manual. Instrument familiarization, base unit front view. The power switch is located on the top left corner of the base unit. Below it is the USB port. The concave area of the base unit is the cell compartment. Inside the cell compartment are the photodetector, lamp, and cell clip. On the right side of the base unit is the cell current switch. Base unit back view. On the back of the base unit are the cooling fan, serial number label, fuse requirements label, power entry module, display power entry, keyboard connection port, a port to connect an optional printer, the display data connection port, serial port connection, and the network, serial, and Ethernet ports for LIMS. Display unit back view. On the back of the display unit are the cooling fan, display AC power cord, and the display data cable connection, connecting the power supply. Be sure the main power supply switch and the cell current switch are in the off position. Attach the correct power supply cord to the back of the coulometer. Make sure the plug is pressed firmly into the power entry module. Connecting the keyboard and display. Connect the keyboard to the back of the base unit using a small flat blade screwdriver to fasten the connector in place. Attach the power supply cord coming from the display to the back of the coulometer. Use the 15-pin cable to connect the display assembly data connection to the coulometer base unit and the display. Hand tighten the attached thumb screws on both ends. If using a laboratory information management system or other network device, connect one or both of the network cables. Connecting the serial switch box to the coulometer. A serial switch box is used to connect the CM5017 coulometer to any additional autosampler systems. Connect the switch box to the coulometer by plugging one end of the cable into the central serial port on the switch box and the other end into the serial port on the coulometer, tightening the screws on the cable. The leftmost port on the switch box can be used to connect a CM5200 total carbon autosampler furnace, while the rightmost port can be used to connect a CM5240 total inorganic carbon autosampler. Turn the switch to CM5200. Connect the coulometer power cord to the power conditioner. Connect the power cord to the power conditioner. Connect the power conditioner power cord to the correct AC power supply. Only the coulometer should be connected to the power conditioner, even though it has 2 outlets. Connecting the optional printer. The optional printer is supplied with the power cord, parallel printer cable, printer ribbon, and roll of paper. Connect the 25-pin end of the parallel printer cable to the parallel port located on the back of the CM5017 coulometer. Connect the 36-pin Centronics end of the printer cable to the matching port on the printer. Connect the power supply cord to the printer and an appropriate outlet. Turn on the printer power. Insert the printer ribbon and paper roll into the printer as per the instructions included with the printer. End of CM5017 coulometer assembly. Assembling the CM5200 auto sampler furnace. Parts included: the CM5200 base unit. The unit also includes a US or European power cord, 3 U-tube connectors for the scrubbers, a 12/3 ball scrubber tube, a 1/8 inch plug fitting, a 4-pack of medium-sized unions, a 10-pack of small-sized unions, a 12/3 socket assembly, a pack of ceramic insulation, a pack of 500 tin boats, a transfer line catalyst to post scrubber, a transfer line valve to catalyst, a serial cable to connect the CM5200 to the coulometer, O-rings for the ball fitting, a catalyst U-tube, a large volume combustion tube, curved forceps, membrane forceps, a spatula, 120 inches of Teflon tubing, 2 scrubber tube assemblies, a ball socket clamp and smaller ball socket clamp, 1 ceramic tube, 29 position carousel, and the CM5200 operation manual. Setting up. Remove the front door and carefully remove the packing material from both sides of the furnace. Connecting the power cord, serial cable, and gas lines to the auto sampler furnace. Be sure the main power switch on the CM5200 is in the off position and connect the power cord to the lowest outlet on the left side of the furnace. Be sure to press all the way into the socket. Connect the other end of this cord to an appropriate AC power outlet. For the serial connection, use the serial cable provided. One end goes to the CM5200 and the other side goes to the switch box marked CM5200TC. The switch box is used to switch between the two auto samplers. Connect the CM5200 auto sampler furnace to the coulometer via the switch box by plugging the larger end of the RS232 cable to the RS232 interface on the back of the auto sampler, and connect the other end of the cable to the CM5200 serial port on the back of the switch box. Use the screwdriver to tighten both ends in place. Preparing the oxygen tank and carrier gas line. For the gas lines, use the tubing, fittings, and ferrules provided. Cut an appropriate length of Teflon tubing to connect the oxygen tank to the carrier gas in fitting. Use one of the 1/8 inch compression nuts and ferrule set provided to connect the tubing to the carrier gas in fitting. Use the other compression nut and ferrule set to connect the carrier gas outline that goes to the coulometer. Use the small adjustable wrench to tighten the compression nut on both of the fittings, but don't over-tighten. The CM5200 auto sampler furnace requires the use of UHP 99.99% pure oxygen as a combustion and carrier gas. The oxygen tank should be equipped with a 2-stage regulator capable of accurately delivering 10 psi of pressure. The regulator should be equipped with fitting that allows the secure connection of 1/8 inch Teflon tubing. Because of the wide variety of tank sizes and regulator configurations, the user should consult with their gas supplier to determine the proper setup. Taking out the CM5200 furnace assembly. Remove the front door and loosen the thumb screws on the furnace latch plate. Lower the latch plate and pull out the furnace assembly. Installing the combustion tube and catalyst tube. Place a small piece of ceramic insulation at the bottom of the furnace. Then lower the combustion tube into the front well of the furnace. Prepare the U-shaped catalyst tube as per the manual. Note, for this demonstration, the tube is not filled. Once filled and prepared, use medium unions with the zip ties to close the tube. Place the ceramic insert into the back furnace well and put the U-shaped catalyst tube into the ceramic insert. Gently make sure the insert and tube are pushed all the way into the well. Then push the furnace back into the unit and tighten the latch plate in place. Connecting valve to the catalyst tube. Thread on by hand the brass nut of the connector line to the brass valve fitting and use an adjustable wrench to tighten. Attach the other end of the line to the U-shaped catalyst tube. Place some ceramic insulation around the combustion tube when everything is in place. Install the transfer line. Install the transfer line from the U-shaped catalyst tube to the post scrubbers, attaching one end to the catalyst tube and leaving the other end hanging until the post scrubbers are set up. Connecting the combustion tube. Connect the Teflon tubing line to the inlet tube of the combustion tube. Then raise the combustion tube to the sample valve ball joint fitting and clamp the tube into place. Tighten the clamp screw to lock it in place. Connect 12/3 socket assembly and ball assembly. Connect the socket assembly to the fitting mounted on the panel. Use the ball socket and small clamp to attach the parts together as shown and tighten the clamp in place. Use an adjustable wrench to tighten the nut to the fitting mounted on the panel. Filling and connecting the scrubber tube assemblies. Note that the scrubbers in the video are empty just for demonstration purposes. They should be filled when you are actually assembling the unit. Filling the post scrubbers. Place a plug of quartz wool into the end of each of 4 clean, dry scrubber tubes. Fill the first tube with reduced silver, followed by a plug of quartz wool. Fill the second tube with loosely packed magnesium perchlorate, followed by a plug of quartz wool. Fill the third tube with acid dichromate, followed by a plug of quartz wool. And lastly, fill the fourth tube with loosely packed manganese dioxide, followed by a plug of quartz wool. Connecting the post scrubbers. Once filled, connect the post scrubbers. For each connection, slip a screw cap over the tubing end post followed by an O-ring. The O-ring is positioned approximately 1/4 inch down on the post. Make sure that the post and the O-ring are clean and that the post is smooth before assembly. A light application of silicone grease to the O-ring may aid in assembly. Screw the caps onto the ends of the scrubber tubes, making sure that each tubing is connected to the proper end of the scrubber tube. The outlet ends of the scrubber tubes are joined by U-tubing. Clip the scrubber tube assembly to the front furnace plate so that the silver scrubber is on the right and the manganese dioxide scrubber is on the left. Then connect the post scrubber assembly to the auto sampler. Attach a fitting and O-ring to the 2 open ends of the assembly. The tubing with the large ball joint goes on the silver scrubber, while the tubing with the small ball joint goes onto the manganese dioxide scrubber. Tighten the fittings until everything is connected. Again, note that the scrubbers in the video are empty just for demonstration purposes. They should be filled when you are actually assembling the unit. Apply vacuum grease. You can use vacuum grease for the ball joints to ensure there is no gas leakage from the system. After applying the grease, reconnect the joints, reattaching the combustion tube with a clamp. Leak checking the CM5200 auto sampler furnace. Use a plug fitting to close off the carrier gas out on the back of the auto sampler. Tighten it using a wrench if necessary. Then watch the ball in the left flow meter. If the ball sinks all the way to the bottom, the system has no leaks. This will take a few minutes because the system needs to pressurize. If the ball doesn't sink to the bottom of the flow meter, you will have to check all the connections to determine where the leak is. End of assembling the CM5200 auto sampler furnace. Running the CM5200. CM5200 front control panel. The control panel has the main power button, valve cycle button, and full carousel cycle button. The full cycle button performs a complete cycle of the CM5200 without the use of a coulometer. It causes the carousel to rotate one sample position, and then it cycles the sample valve from ready to purge to drop. We also have two PID temperature controllers, each with its own power switch, one for the front heater and one for the rear heater. At the top we have LEDs that indicate the state the system is in. There is an LED for ready that indicates ready to run a sample, purge for purging a sample, and drop to indicate dropping a sample into the combustion tube. Now we will turn on the PID temperature controllers. Each one shows the current temperature with offsets and the set point temperature. To set the temperature, press the star key and hold it down, and use the up and down arrow keys to adjust the temperature. Note that the cycle buttons must not be touched when the auto sampler is being controlled by the coulometer. Temperature controllers. The temperature controllers should be on and the furnaces at operating temperature prior to starting analysis. Setting up the CM5017 for use with the CM5200. Check if the USB flash drive is connected, and if not, plug it in. Turn the main power switch on while leaving the cell current switch in the off center position. Confirm that the optional printer is properly connected and that the power is on. Screen calibration. We'll begin with screen calibration. Follow the instructions on the screen to calibrate. Screen calibration should only be done when users change. Setting parameters. Select System Parameters. Change settings. Here you can choose the form you'd like your final results to be calculated in. If you choose carbon, the results will be presented in the form of %C, % carbon, or you can choose %CO2 or %CO3. Here, based on the type of your samples, you can choose initial sample measurements entered by weight, volume, or units only. If the units only option is selected, results will be presented as amount of carbon in micrograms. The units range from micrograms to milligrams or grams. Here we choose milligrams. The percent difference criteria is 0.1% by default. This is the number the system uses to decide when to stop. The system takes a sample reading every 1 minute by default, compares the last two readings, and if the difference is less than 0.1%, the measurement stops. Factor is used if you have some diluted or concentrated samples. You can enter a factor here so the system will calculate and give you the final values. Number of readings is the minimum number of sample readings the system will take per sample. In this case, we chose 8, but this number can be any number higher than 2 and lower than 45. This is the number of readings the system will do without using the percent difference criteria. After running this many readings, the system will start comparing the last 2 results to decide when to stop. Interval is the time in between sample readings. The default is 1 minute, but you can increase or decrease the interval. This will affect total measurement time for a sample. Timing method. If auto endpoint is selected, the system will use previously set percent difference criteria to decide when to stop. If fixed number of readings is selected, then the system will only run the number of readings you selected previously. In our case, we chose 8 readings, so the system would take 8 readings for each sample and then stop. Sampling method. Here, if you have a manual system, you would select Manual. We will select Auto Sampler for this system. Auto Sampler type. Here we can select the CM220 for measurements of inorganic carbon, or in our case, we will select CM5200 for total carbon. The kilometer can run only one autosampler at a time, and each time the appropriate autosampler must be selected. Printout format. Choose Standard Format here. The calibration test format is only used to check if the electronics are working. Sample entry method. Information about samples, such as sample names and weights or volumes, can be entered from the USB disk or manually. Here, Analyst ID and Instrument ID can be changed. This is convenient if you have more than one user. When finished, press F4 to get out. When you press back, the system will save the changes on the USB and return you to the System Parameters screen. Print settings. Even if the printer is not attached, you can select this to view the parameter data. Press F4 to get out. Setting date and time. Press 1 to enter the date and press 2 to enter the time. Press F4 to return to the System Parameters page and press back once more to save all the changes on the USB. Preparing the carbon coulometer cell. The cell has 2 compartments. The larger one is the cathode compartment and the smaller one is the anode compartment. There are a few steps to preparing the coulometer cell. Step 1. Place the magnetic stirrer in the cathode compartment. Step 2. Fill the anode compartment's lower bulb with potassium iodide until it is about 1/4 to 1/3 of the way full. Step 3. Using the gallon jug of cathode solution, fill the cathode compartment up to the 100 milliliter line. Step 4. Using the smaller sized bottle of anode solution, fill the anode compartment until it is slightly less full than the level of the cathode compartment. Step 5. put the tops on the compartments. The cathode top has a platinum electrode and an inlet tube. The anode top has a silver electrode. After putting both tops on, adjust the heights of the platinum electrode and the inlet tube so that they do not interfere with the magnetic stirrer. You may have to lift the electrode and the inlet tube slightly or lower them down if necessary. Both the platinum electrode and the inlet tube should be just slightly above the magnetic stirrer. Step 6. After adjusting the heights of the inlet tube and the platinum electrode, turn the cell to adjust the cathode top. You want the platinum electrode in the inlet tube to be as far away as possible from the light path going through the bottom part of the cell when it's placed in the coulometer. To do that, make sure that the top of the silver electrode on the anode compartment is in between the inlet tube and the platinum electrode from the side angle. This ensures that the platinum electrode and the inlet tube will not interfere with the light path. Step 7. For the final step, take a clean Kim wipe with a small amount of methanol and wipe the sides to remove potential fingerprints or any other residue that will interfere with the light path. Now the cell is ready to be placed in the coulometer. Placing and connecting the cell. Place the cell into the cell compartment of the coulometer. Before connecting, check that the cell current switch is in the off position. While the switch is off, connect the cathode using the black connector and the anode using the red connector. Then place the inlet tube through the holder on the right in this case, because the furnace is placed on that side, and place the outlet tube through the holder as well. Attach the inlet tube to the check valve that is connected to the CM220 auto sampler. The check valve ensures that the carrier gas moves in one direction toward the cell. Run cell setup. When the cell is placed in the coulometer and connected, the cell current button is still in the off position. Make sure the CM220 auto sampler furnace is connected and on, and the carrier gas is going through the cell. Now you can go to Run Cell Setup. The system will use this number to determine 100% transparency. You can move the cell slightly left or right to maximize this number. The number should be between 2700 and 4000 and stable within 10 digits. At this time, it is best to leave the system 5 to 10 minutes to stabilize. When the difference is less than 10 digits, press Next. The system will regard the final number as 100% transparency. Titrating the cell. Press Start Analysis. In this step, we'll titrate the cell down. The cell should be at 100% transparency, and the cell current should be 0. Flip the cell current switch to the on position. The cell current should change to 200 milliamps and the transparency should begin decreasing. The cathode solution will slowly change color and become bluer. The percent T number should decrease to 29.5% plus or minus 0.1. When it does, the titration is complete. While waiting for transparency to decrease, we recommend leaving the coulometer 45 minutes to an hour, even though 29.5 will be reached relatively quickly. This leaves enough time for the system to stabilize. After waiting for this period, the cathode compartment's contents should be blue, %T should be 29.5, and the system is stable and ready. After that, press Next. Loading the samples into the carousel, folding the tin boats. The samples are weighed into tin boats, folded, and placed in the carousel. The sample is weighed in the boat. The boat is pressed with tweezers above the sample as shown, and then folded over. The boat is folded again until it finally appears as shown. Placing the carousel on the CM220. After placing 2 blanks and the rest of your samples in tin boats into the carousel is ready to be placed on the top of the CM220. Make sure the metal guide on the carousel aligns with the notch on the top of the CM220 so the carousel will set properly on the instrument. Check the serial switch box. Make sure the switch box is set to the CM220 TC position. Choosing the number of samples. Now when the cell is titrated, we can press Next and we can enter the number of samples. Here we can enter how many samples we want to measure. Be sure to include the blank measurements in your number of samples. You can enter all the samples and their information manually or import from the USB flash drive if that option was selected in the sample entry method in the system parameters previously. Data from a USB must be exported in CSV format to be read properly by the coulometer. When the samples appear, you can review them, and if there is an error, press the Escape key, or if all is correct, press F4 to accept. Now the system is ready to begin analysis. Press Begin Analysis. The coulometer will tell the autosampler to start. All 3 LEDs on the CM220 will flash to indicate they received a start, and the carousel will turn to drop the sample. The sample valve will then cycle from ready to purge, and after the specified purge time, to drop position, to drop the sample into the furnace for combustion. When all the samples have been analyzed, press Done on the CM220. Shutdown of the CM220 and CM220 system. When you are finished with the measurements, or finished for the day, disconnect the autosampler from the cell and coulometer, switch off the cell current, and then switch off the coulometer. Remove the cell and dump the solutions, and then clean the cell so it's ready for the next time you do measurements. A cooling furnace causes a partial vacuum development inside of the flow system. Under uncontrolled conditions, this vacuum will draw cathode solution into the furnace if the system is left connected to the coulometer cell. This is a potentially dangerous situation. A check valve must be installed between the furnace and the coulometer to prevent the siphoning of coulometer solution into the furnace. Whenever the furnace temperature is reduced or the furnace is turned off, disconnect the furnace carrier gas outlet line from the coulometer cell. Switch off the CM220 autosampler furnace, but leave the carrier gas flowing for another 5 to 10 minutes and do not open the furnace until it is cooled off, or else the combustion tube might break. Thank you for joining us for this demonstration of a CM220 unit from UIC Inc.